we have two different material. We have concrete. We have stress strain curve for concrete. Strain, stress looks like this one. Can you watch? The curve is going down. And the highest value, do you remember? The highest value here called F prime C. We have tangent for this linear relationship, this tangent called E concrete, Young's modulus of concrete. So F prime C, most of the time, you have to figure it out by a compression test, or it will be given in the problem in PSI or KSI. E concrete, which is the tangent for the linear relationship, you can get it by, I believe, 75,000, I think, square root F prime C. And this value will be in PSI F, and FC prime must be in PSI. So I can figure out the Young's modulus of concrete. We have another material which called steel reinforcement. Steel reinforcement, we have two situations for stress strain curve. Sometimes your stress strain curve, we have plateau for yielding and then strain hardening, something like this. Or for mild steel, your curve looks like this. Guys, the curve didn't go down like concrete. Okay? So the slope of the linear relationship here can be called E steel. E steel is a certain value. You can memorize it all the time, 29,000 KSI or 29 million PSI. E steel. We have something called modular ratio, N equal E steel divide E concrete. So probably in the problem, I will not give you N. Probably I will not give you E concrete. Probably I will not give you E steel. But sure, I will give you what is the value of F prime C. What is the value of F prime C? So from F prime C, I can figure out what is the value of Young's modulus of concrete, which is the denominator. For E steel, I have to memorize, I have to remember what is the value of E steel, Young's modulus of steel, 29 million PSI. If you divide this value by this value, I can figure out what is the value of modular ratio. No, it's 57,000, I believe. Okay, no problem. Go back to the first week. No, 57, I think. First week, we have here a value for all of this stuff. There you go. 57,000. Okay, and one more time, do you remember last time we have another phenomena for concrete, which is that tensile strength of concrete is a function of F prime C. Fr, which is tensile strength of concrete, equal 7.5 square root of F prime C. All of this equation from American Concrete Institute is ACI 318. Okay, so all of this equation you have to remember. So right now I can add here one more. Fr equal 7.5 square root F prime C. Actually, we have another term here, lambda, for lightweight concrete, but we don't care about this type of concrete right now. Do you remember what is the main benefit or what is the main purpose of FR? Help you to figure out what is the value of cracked moment. Cracked moment will be used in pre-stressed, I believe. Okay, so cracked moment will be calculated using what is the tensile strength of concrete. Okay, Burak? Just we stopped at this example last meeting. We have reinforced concrete cross-section with 3 rebars, number 9. So the total area of steel equal 3 inches square. And I told you what is the story behind how can I get this number, 3 inches square. We have depth 17. Depth means the total distance to the steel reinforcement from the top to the steel reinforcement. We have width 12 inch. We have cover 3 inch. We have applied moment. How much? 70. And this moment is greater than the cracking moment. That means concrete cracked. That means concrete cracked. So if you have cracked concrete, we have something called neutral axis. Part of concrete which is under compression, still good. So we have concrete here under compression, still working. The width of this concrete equal the total width of the cross section, which is 12. This depth, I don't know what is the value of this depth. I will assume it dn, depth of neutral axis. What about concrete on the other side? Cracked. What does it mean? Remove it. We have only steel reinforcement. This steel reinforcement will be converted to equivalent concrete. This is concrete equivalent to this steel reinforcement. How can I make this conversion between steel and between this material and this material? Using modular ratio N time the original area of steel, which is area steel. N is given by 9. Area steel is given, or I can get it 3. So the equivalent area of concrete equal 27 inches square. Can you remind me what is the distance between center line of this equivalent concrete to this neutral axis? Do you remember? Yeah. The total depth between this steel reinforcement to the top is 17. And the distance between the top to the neutral axis is dn. So the remaining distance will be 17 minus dn. Thank you. So if we take moment about neutral axis, moment means area time distance. What is the area above the neutral axis? It's 12 time dn. This is the area. And this area has lever arm between the centroid to the neutral axis. What is the distance between centroid to neutral axis? It's dn divided 2. This is the area above the neutral axis equal the area below the neutral axis. We have n area steel, which is the equivalent concrete area. Time, what is the distance between this centroid of this area to the neutral axis? It's 17 minus dn. If you would like to write it with symbols, I highly recommend to remove 17. I'm sorry, remove 17 and put it here d. Your depth is this value. The distance between reinforcement to the top called d. So we have an equation. Go ahead and put your numbers. Okay. Okay, this one also can be called B. B is the width of the cross section. So B is 12 times dn square divided to equal n 9 times area steel 3 times depth 17 minus dn. So we have 6 dn square plus 27 dn minus 459 equals 0. I moved some terms from one side to the other side, so you need to convert the sign from positive to negative or from negative to positive. Okay, so I have only one unknown. I have equation from of the second order, so I can figure out what is the value of dn. I will use my calculator. 6 and 27 and negative 459. We have 6.8. We have another one which is negative, is rejected. So we have dn equal 6.8 inch. So the depth of the neutral axis equal 6.8. Okay, so I will do it here. So we have cross section like this. This one is 12. This one is 6.8. That's right. Yes. Yeah. We have neutral axis. We have equivalent concrete here with area equal 27 and the distance between this centroid and the neutral axis, how much? Depth 17 minus dn 6.8. This value will be 10.2. What is the moment of inertia? I, for this cross section. For the first part, we have parallel 12 times perpendicular 6.8 cube over 12. We have another part for this one, which is the area 12 times 6.8. What is the distance between this axis and the original neutral axis? It's 3.4 square plus parallel time perpendicular cube over 12 for this one is nothing. I will use only the other part, which is the area 27 time this distance between the origin to the neutral axis is 10.2 square. For this one, I neglect the part of moment of inertia, which is BH cube over 12. I only used area time distance square. As you remember, your inertia for anything equal ph cube over 12 plus another term area time d square. For the first part of concrete under compression, I used both of them. For the equivalent concrete for steel, I neglect the first part and I used only the second part. Why? Because the first part is nothing, just very small part. So 12 times 6.8 cube over 12 plus 12 times 6.8 times 3.4 square plus 27 times 10.2 square. Your inertia will be 4066.8 inch to 4. Your stress for concrete equal M Y of concrete divide I. Stress of steel equal N modular ratio. I have to convert back to steel. So My steel divide I. Do you know what is the value of M? Is given. The moment, the applied moment equals 70 kb/foot. We have 70. What is the value of Y of concrete? What is the value of I? I is 4066.8. What is the value of Y of concrete? Do you know what is the value of Y? Yeah, Y is measured from neutral axis to the top of concrete. What is the value of YC here, or Y concrete? 6.8. We have issue with units. This one is skip foot. I don't have problem with skip, but I have problem with foot because this distance in inch and this moment of inertia in inch to 4. So everything in inch. So I need to convert this moment from kb foot to kb inch. So I have to multiply it by 12. So I can figure out the final stress will be 70 times 12 times 6.8 divide 4066.8. Your final answer will be 1.4 KSI, which means kb per inch square. Also, during your homework, you have to put your units. Don't put a number, 1.4, that's it. No, you have to tell me what is the unit of this number, KSI. So stress in concrete, which is compression. Because the top part of this cross section is under compression. So if you are looking for the maximum stress at the top, your Y distance equals 6.8. Compression, how much? 1.4 KSI. If you are looking for stress in steel in modular ratio 9, what is the value of moment? 70. What is the value of YC? The distance for steel reinforcement from the neutral axis. The distance to steel reinforcement, this distance, Y steel. How much? 10.2. I'm sorry, this Y is not YC. 10.2. Divide I 4066.8. We have issue with the units. This one is kb foot. This one is inch. This one is inch to power 4. So we need to convert this one to kb inch. So I have to multiply it by 12. Your final stress here will be 70 times 12 times 10.2 divide 4066.8 times 9 will be 18.96 KSI, which means kb per inch square. This stress is tension or tensile stress because you are talking about steel reinforcement and we expect here in tension and there compression. Please, for steel, don't forget the modular ratio. For concrete, we don't have modular ratio for one reason. Because this cross section is transformed cross section. All of these material are concrete. So we don't need to do anything, just use this equation and that's it. But if you are using this equation with this cross section, we need to convert back this equivalent concrete to steel. So I have to multiply it by modular ratio. Any questions so far? Guys, any questions so far? I will repeat all of this stuff one more time. I will repeat all of this stuff one more time. We have another cross section. The total thickness 23. The depth is 20 inch. The width is 12. We have 4 bars, number 8. Anybody, you should have your table with your hand right now. Anybody can tell me what is the value of area steel? I have my tables also. I open it. So number 8, what is the area of number 8? Yes, 0.79 for only one bar. One bar of number 8. But we have 4 bars, so I need to multiply this area by 4 to get the final or the total area steel. So total area steel will be 4 times 0.79. Your value will be 3.16 inches square. Okay. The moment applied exceeds the cracked moment, so we can expect tension on concrete exceeds the cracked moment, so we can expect crack. So we have something here called neutral axis. Neutral axis. The upper part of this cross section is good because it's under compression. I will assume this depth dn because I don't know where is this neutral axis. I cannot say at the centroid. No, I cannot. I don't know where. And this width, how much? 12. This steel will be converted to equivalent concrete. How much? Modular ratio, which is 10, time area steel, which is 3.16, will be 31.6 inches square. And the distance between centroid of this equivalent area to the neutral axis will be 20, which is the depth, minus dn for the upper part. So the upper part with this centroid about the neutral axis has area 12 times dn, has lever arm between this centroid and the neutral axis dn divided 2, equivalent to the lower part with area 31.6, and the distance or the arm between this centroid and the neutral axis is 20 minus dn. Go ahead and convert or simplify this equation. So we have 6 dn square equal what? 31.6 times 20, so equal 632 minus 31.6 dn. So if you make some arrangement, plus 31.6 dn minus 632 equals 0, the only unknown is dn. So I will use my calculator to solve this one. 31.6 negative 632. Your value will be 7.9 inch, and the other one will be negative, can be neglected. So your depth of the neutral axis, this one, equals 7.9 inch. Same story. So right now, we have a cross section with this part, and we have neutral axis. This width 12, this depth 7.9, I think. 7.9, that's right. Yes. And we have equivalent of concrete. How much? Area equal 31.6, and this distance, which is d20 minus 7.9, equal 12.1. Go ahead and calculate your inertia. Inertia for the upper part will be will consist of two terms. Parallel time perpendicular cube over 12 plus area 12 times 7.9. This is the area. This one is the area. What is the distance between this centroid and this neutral axis? Half 7.9, which is 3.95 square. Plus, for this part, I will neglect parallel time perpendicular cube over 12. I will use the area time this distance square. That's it. So I can figure out the moment of inertia for the transformed section will be 6,598.7 inch to 4. For concrete, we have sigma concrete equal my concrete divide I. Anybody can remind me what is the value of y concrete? Y concrete means this distance, which is 7.9. Okay, go back to the problem. The problem did not ask for stress. The problem asked for what is the moment. We are looking for moment. Determine the allowable resisting moment. It's okay. The problem asked for moment and give me stress in concrete. FC or sigma C is given. 1,350. It's okay, no problem. The same scenario. So sigma concrete or F concrete is 1,350 is given. And I'm looking for moment. What is the value of YC? 7.9. What is the value of moment of inertia? 6,598.7. The same scenario, the same story. Nothing new. So what is the value of M? This moment related to concrete. This moment can be supported by this concrete under compression. Okay, what is the value of M? 1,350 times 6,598.7 divide 7.9. This value equal 1,127,625.9 bound inch. This one is bound per square inch. This one in inch. This one is in inch to 4. So the final answer of this moment will be bound inch. Do you remember last meeting, I believe? I don't like moment in bound inch, so I will convert it to bound foot by dividing it by 12. It will be 93968.8 pound foot. If you are feeling this value is too big, so you can convert it to kib foot by dividing it by 1,000. It will be 93.9 kib foot. It's a good number. It's very easy. 93 kib foot. But the first one, it will be 1,127,600. It's too much to read it. But if you tell me, hey, this moment is 93.5 kb foot, it's perfect. Okay, this is related to what? Concrete. What about steel? We have another part in this cross section. We have steel. Sigma steel equal N my steel divide I. What is the value of Y steel? This is the value of Y steel, 12.1. What about the allowable stress for steel? It's 20,000. It's given. So 20,000 equal modular ratio 10. We are looking for moment. What is the value of ys? It's 12.1. What is the value of moment of inertia? 6,500. 98 point something, 0.7. So the only unknown is m. What is the value of m? Just a moment. 20,000 times 6,598.7 divide يطلع I'm sorry. The value will be 10,90694.2 pound inch. Be careful about your unit. During the grading of homework, I told you what is your unit. So this one in PSI, which means pound per square inch. This distance in inch, this moment of inertia in inch to power 4. So everything in pound and inch. So your final answer will be pound inch. I don't like this big number, so I will divide it by 12 first. It will be 9891.18. Okay? Pound foot. If you are feeling still big, so I will divide it by 1,000. It will be 90.8 kb foot. So this moment related to steel. So final answer, the moment that concrete can support equal 93.9 kb foot. But the moment that steel can support in the cross section equal 90.8 kb foot. What is the final moment that this cross section can support? Is it the biggest one or the smallest one? Any answer? This moment will be good for concrete only. This moment will be good for steel only. What is the moment that will be good for the cross section? Because the cross section is consists of two parts, one concrete, one steel. So what is the final moment that will be good for both of them? The smallest value or the biggest value? Any answer? Smallest. Good. Smallest value, 90.8 kb foot. Perfect. The smallest value. Smallest value will be good for steel and will be more safe for concrete. But if you choose the biggest value will be good for concrete, but will be unsafe for steel because steel can support smaller. Okay, so your final answer for this problem, we are looking for what is the allowable resisting moment. This cross section can support moment equal how much? 90.8 kb foot. We prefer to make your final value of moment pound foot or kb foot. We would like to make this number very simple. We don't like to see 1,100,000, 1,000. We don't like this. We like very simple number. So can you see the original number from your calculation was 1 million. I converted it to 93, so I can figure it out. 93 is very simple, but just I only change the unit from pound inch to kb foot. Burak, do you have question? Monday is a holiday. It's a good question. Yeah, we don't have meeting on Monday. We don't have meeting on Monday. It's a holiday, but the homework is still due date. The due date is still Monday at 11. Okay, go ahead. I'm talking about Alan. The question for Alan. Monday is a holiday, so we don't have live meeting, but the homework due date still Monday at 11. So what's your question? Yes. No, not 6dn. It's 6dn square. dn square. Because this is the area 12 times dn. And this area must be multiplied by this distance, which is dn divide 2. So 12 divide 2 is 6. dn times dn is dn square. So the left side is dn square, not 6dn. Okay? Okay. So just a reminder, we have 3 stages for the concrete. The first stage, uncracked, and we learned how to get the uncracked moment. The second stage, concrete cracked, but still within the elastic limit. We learned how to figure out the value of moment from this problem, the current example. Then finally, your cross section reached the ultimate stage. So we are talking about ultimate behavior or ultimate moment for the cross section. And this stage will be used in ACI. Next week, we will focus on this stage, ultimate. We will design concrete when reach to ultimate. We have a neutral axis also. The top part under compression, but the compression or the compressive stress distribution on the upper part looks like this, parabola. At the neutral axis 0 and increase until the top fiber. The lowest part of concrete under tension, it will crack. And the only part is working at the bottom is the steel reinforcement. The same sequence, concrete under tension cracked. If the concrete cracked, we can remove it and in the trash, remove it to the trash. I will close my email. Okay. The depth of the neutral axis, I will call it C. The distance between the top and the neutral axis, I will call it C. It's very hard, not easy, to figure out this shape, parabola. We don't like parabola because it's not second order or third order, it's something different. So we don't like this parabola. So I will convert, it's not me, but the standard ACI asked to make equivalent for this shape of parabola. Can you watch? This shape of parabola looks like this. So I will convert it to rectangle, equivalent rectangle like this. So this parabola is converted to this rectangle. But with depth smaller than C, can be called A. So I did this equivalent of rectangle like this, but smaller than C. So this one was A, but the original shape with depth C. The relationship between A and C, A equal beta 1 times C. How can I figure out the value of beta 1 from this table? Based on what is the value of F prime C of concrete. If F prime C between 2,500 to 4,000, beta equal 0.85. If the value of F prime C between 4,000 and 8,000, you can get the value of beta 1 from this equation. If the value of f prime c greater than 8,000, f prime c equal 0.65. So you need to go back to the problem. What is the value of f prime c? Then using this table to figure out what is the value of beta 1 to make a relationship between the actual depth of the neutral axis and the equivalent depth of this rectangle A. And this value of stress not equal f prime c. No, will be 0.85 f prime c. So this rectangle, I can figure it out right now. The depth is A. This value of stress equal 0.85 f prime c. And the stress in steel reinforcement equal F yield. Any questions so far? I will show you something very important. Please print it in your mind. I will explain something in 3D and please print it in your mind forever. The cross section of concrete looks like this. And we have steel reinforcement at this location. That's right. We have moment. We have moment like this. This moment will make tension at this side and compression at this side. Please don't write, just look to me and watch me first. Between the tension side and the compression side, we have something here called neutral axis. The actual depth of this neutral axis called C. Concrete in compression has this parabola of stress, but we will convert it to this rectangle with depths smaller than C, a little bit. A equal beta 1 C. So we have here something looks like this. This stress is compression stress. So if you look from this side, you will find this rectangle and this value equal 0.85 F prime C. And this depth equal A. And this width equal B. Do you agree? Do you agree? This is the actual behavior of the beam. Actual behavior of the beam. This stress block at the top looks like this, with depth A and this height of stress 0.85 F prime C, and this width equal B. If you would like to make equivalent for this stress as a force, capital C, this capital C force in concrete equal volume of this stress block. Can you tell me what is the volume? What is the volume of this shape? Volume of this shape, it looks like cuboid or something like this. So the volume will be 0.85 F prime C which is this value, time B, which is this value, time A, which is this value. So I multiplied the three values together to get the volume of this shape of stress. This shape is the volume of this shape, which is called capital C, equivalent compressive force in concrete. Okay? On the other side of this cross section, we have tension in steel reinforcement. Concrete in tension is cracked, removed in the trash. So we have tension. And we know if you are looking for force, this force will be F yield time area steel. Because stress equal force divide area. If you multiply area times stress, you can get force. So force or tensile force in steel equal yielding stress of steel time area steel. Any questions so far? Guys, any questions so far? Perfect. So the tensile force in steel equal area steel F yield. The compressive force in concrete equal 0.85 F prime C time A time B. And I told you what is the story behind this equation. 0.58 is the value of stress. B is the cross section width, B. A is the depth. We have shape, looks like cuboid. We need to figure out what is the volume of this cuboid. So you need to multiply this distance by this value, by this value, you can get the volume. This volume is the equivalent compressive force in concrete. The tensile force in steel is more simple, so just stress time area steel, which means F yield time area steel. Okay? Do you agree? I think you agree. From last semester, we know if you have something in equilibrium, summation forces in x direction equals 0. So this cross section is in equilibrium. So the summation of all horizontal forces must equal 0. So capital C must equal capital T. The compressive force in concrete must equal the tensile force in steel. So 0.85 F prime C A B equal area steel time F yield. From this equation, I can figure out what is the value of A. It will be the only unknown. Okay? One more thing. I need someone, and I will give him 3 points in the coming exam, to tell me what is the vertical distance between C and T. What is this distance is? What is the distance between the compressive force, which is at the centroid of this shape, and the tensile force in steel reinforcement? No. Not C divide 2. D minus C, no? T minus dn, no? Guys, I didn't mention we have dn here. We don't have dn. What we have this distance A from the top to the bottom of this stress block. And this force at the centroid. That means the distance between this force and the top will be A divide 2. And the distance between shear reinforcement to the top of the cross section is D. So the distance between this force and this force will be D minus A divide 2. I can explain it one more time by using this slide. If you look to this slide, the distance between here and the top, we assumed it to be A. And this force at the centroid, so this distance will be A divide 2. And the distance between shear reinforcement and the top of the cross section is D. So the distance between this force and this force will be D minus A divide 2. Why you are looking for this distance? Because if you take moment at this location, your moment or your final moment will be T time D minus A divide 2, which is area steel time F yield T time D minus A divide 2, the distance between the two forces, or equal C time D minus A divide 2, or equal 0.85 F prime C AP time D minus A divide 2. This term equal to this one, and this term equal to this one. And how can I get this arm or this distance? Is the distance between the two forces. Let me do one example, because you have a homework. Only one example, and that's it. Okay, Burak, but you switched it. T, not T, it's D, depth, minus A divide 2. Thank you. So I will go through this example. It's very simple. This method is very, very, very simple. Guys, I have to say this story. We have a cross section, and we are looking for ultimate moment. So the problem asked for ultimate moment. That means you are in ultimate stage. Previous example asked for allowable moment. That means you are in the stage of allowable stress. So be careful, because someone will tell me, hey, this one asked for moment and the second one asked for moment. Yes, but this one allowable moment. We have a different story. This one is ultimate moment. We have a very a complete different story. So we have neutral axis. Concrete in compression. Hey, I forgot something. This neutral axis has a depth C, small c. Concrete in compression will be under equivalent stress block. Looks like this. How much? Here, 0.85 F prime C. What is the depth here? It's a little bit smaller than C, which is A. steel reinforcement will be under tension, will have tension tensile force T equal area steel times F yield. And we have here equivalent compression force capital C. So capital C equal 0.85 F prime C time A time B. Capital T equal area steel time F yield. Because this cross section is in equilibrium, so capital C equal capital T. So I can say 0.85 F prime C time AB equal area steel time F yield. Can you put your number? F prime C 3000, so 0.85 time 3000. What is the value of A? This distance A, I don't know. What is the value of B? The width of the cross section 14 equal. What is the value of area steel? We have 3 bars, number 9, so the area will be 3 inches square. So we have 3 inches square. F yield of steel reinforcement 60,000. As I told you, the only unknown in this equation is your distance A. I can figure it out. So 3 times 60,000 divide, your value will be 5 inch. We are looking for moment. What is the value of moment? Your moment, we have 2 options. Your moment equal T times this distance or equal C times this distance. It's up to you. I prefer to use T. It's more simple. So your moment, nominal moment equal T, which is area steel times F yield times this distance D minus A divide 2. Go ahead and put your number. Area steel is 3, F yield 60,000. Your depth, what is the depth of this problem? 21. Your depth is 21. What is the value of A? 5 inch divide 2. That's it. I am done. Very simple. 3 times 60,000 times 21 minus 2.5. Your final will be, in final answer, 330000. Bound inch. Because everything in bound and inch. This area steel in inch square. This one is bound per inch square. All dimension here in inch. So everything bound and inch. I need to simplify this number, make it more easy. So I will divide it by 12. It will be 277,500 pound foot. I will convert to kip. So I will divide by 1000. That will be 277.5 kip foot. This number is very, very, very good. 277 is better than 3,330,000. So your final moment of this cross section equal 277.5 kip. It's a very, very simple story. The story one more time. We have compressive force in concrete. We have tensile force in steel. For equilibrium, both of them are equal. I can figure out the distance A. Once you get the distance A, I can figure out the moment equal T times the distance between the two forces, which is D minus A divide 2. I can get it. The second example, the same exactly. The same, but we have different numbers.